Students, we will continue on the lecture on cupola furnace. So, the basic parts of cupola furnace we have discussed. So now we'll get into different zones of the cupola furnace and how they work. So, the first zone is called as the well, as we can see in the picture. It's the bottommost part of the furnace. So, it's a place where melting takes place. So here, the burning of material takes place, and then molten metal, once the burning takes place, combustion takes place, heat is generated. So that heat is used to melt the metal. So the molten metal will be settled at the bottom. So this is where the molten metal can be collected from the furnace. So next zones are the combustion zone and reduction zone. Sorry, combustion zones and reduction zones. So in the combustion zone, burning takes place. So before getting into that, I would like to discuss the image here. As you can see here, there are layer by layer stacked metal, flux, coke. So here, metal is the material which needs to be melted. It may be either be iron ore or scrap of iron, which needs to be melted. Then there is the flux and coke. So coke is nothing but it's the ignition material, or your coal. Coke is nothing but it's a type of coal. So there are different types of coals: lignite, anthracite, bituminous, coke. So coke is a form of coal which is purer than lignite. So that, and there is a flux. So flux is essentially calcium carbonate. So flux is used for removing impurities from the metal, which we will discuss in detail in the upcoming slides. So I just need to make sure, I need to tell you that these are the materials which are used in the furnace. We will be melting the metal with the help of coke. Coke is the combusting material. So that which is burnt to liberate the heat. So as you can see here, the combustion zone, exothermic reaction takes place. Carbon combines with oxygen, that is coal is burnt, and it liberates carbon dioxide plus heat. Similarly, well above the combustion zone, there is a reducing zone. So reduction zone is the zone where incomplete combustion takes place. So as I said, you need higher amount of air in order to liberate more heat. So there is not sufficient sufficient air which is pumped into the furnace. What happens is that incomplete combustion takes place and reduction zone happens. So if you compare the temperature between the combustion zone and the reduction zone, the temperature substantially differs. So around 500 degrees Celsius variation is there because of the unavailability of oxygen. What happens is the carbon dioxide combines with carbon to form coke. And then there is the melting zone. So melting zone is the zone where melting takes place. So all these zones are within the furnace itself. So in the bottom, when the coal is burnt, heat is generated. That heat moves up to melt the metal. So metal melting, as you can see, iron combines with carbon monoxide to form iron carbide and carbon dioxide. So the iron carbide is the form of iron. So iron does not usually exists in its natural state as pure iron. It combines with carbon to form iron carbide. So that's the Fe3C which we are seeing. So then there are preheating zone and stack zone. Preheating zone is zone which is above the melting zone. So I said the furnace will be about 60 to 80 feet high. So there will be stacks of coal metal flux stacked one above another in the furnace itself. So what happens, the purpose of that stacking is to preheat the material before it's being melted. So once it is preheated, what happens is that it reduces it liberates all its moisture content. So once the moisture content is separated from the material, it becomes ready for combustion. That's the purpose of this preheating zone, to remove the moisture from the material so that it is ready for combustion. It's readily combustible. If it is moist, the wood is slightly damp, what happens? We cannot burn it effectively. So that's the reason we are using the preheating zone to remove moisture from the material. And stack is a storage area. So what happens in a cupola furnace, as I said, when the coal burns, the metal is melted, and I need to mention the purpose of flux here. So flux, why it is used is to remove the impurities from the material, calcium carbonate. So what it does is that it removes the impurities from the metal. So if you are taking iron ore, I said in iron ore, iron is removed from the ore. So how it is done is with the help of flux. Flux, what it does is combines with the impurities and forms a frothy layer, which is a foam-like substance which gets deposited on the top of the molten metal. Since molten metal has high density, it settles in the bottom and the impurities tend to go upwards. So that impurities can be removed from the slag bottom and the molten metal can be removed. So that's a basic working of this cupola furnace. I hope you understood this topic. Thank you. We'll see in another lecture video.